First, why consider all this old stuff when you're looking to get into the profession today? And my answer to that is quite simple. We've always been changing, and over the last 4 decades, I've come to believe that the most important skill you can have for starting a career in GIS is becoming comfortable with change, adapting to and learning new technologies. Therefore, I want to tell you a little bit about the change I've witnessed, so you can see what you can expect in the coming decades, the types of change. We don't know what the changes are going to be, but there will be change. Now, in all honesty, I have no keen insights into the future. Today's norm was quite unlike anything I've experienced in my life. Therefore, might have to have relatively simple predictions about the future. This slide shows how I view recent GIS history. 2 comments. First, it's anecdotal. It's my take on GIS history. It's what I lived through. And I call it recent because there was GIS long before 1980, 1975. We keep tracing it back to when was the term first used in the literature, and that goes back to the 60s. Well, I see it somewhat differently. I trace GIS back through computer cartography, which goes back to the 50s, but I trace computer cartography through cartography back centuries. So it's sort of a long history of things. Now, if you think about this in ESV terms, the workstation era was when ArcInfo was the primary software product. Then in the desktop era, it was ArcView, ArcGIS Desktop, and now ArcGIS Pro. And today, ArcGIS Online appears as really sort of the core product. And I use the term ubiquitous for this last section to underscore the idea that with online services, we're not tethered to a particular machine nor location. In fact, we could initiate some relatively heavy-duty analyses from a smartphone while sitting in the park. Next slide, please. Here is showing the transition periods. Note the long transition from workstation to desktop, about 15 years. Followed immediately by another transition going from desktop to today's ubiquitous. So in laying out recent GIS history in this manner, we have 3 time periods, labeled in red, workstation, desktop, ubiquitous, and 2 transitions. But we also have an interesting year, 2005, where there's a transition to a transition. Next slide. And I'm going to go through these quickly and in order. The workstation era. ArcInfo, Esri's ArcInfo, first released in 1981, but really 1982, was the dominant software. At the outset, and for the first 10, 15 years of this period, in order to do GIS, you needed to be highly trained. You needed to know Unix, you worked at the command line, and you made life easier by scripting as much as possible in a macro language. GIS was strongly producer goods oriented. Users were almost exclusively GIS professionals. They worked primarily at 3 places: government agencies, large utilities, and universities. This is the era that's sometimes called the GIS high priesthood. When I taught ArcInfo in class during that time, we spent the first few weeks making sure everyone was comfortable with Unix. We then went through the syntax of many different commands, and it was several weeks into the semester when the first map was finally produced. Think about that. The semester started at the beginning of September. You made your first map in the beginning of November. Next slide. Moving from this era into an era that you're probably familiar with, the desktop era, there are some absolute changes. Doing GIS changed from running command line software on a Sun or Silicon Graphics Unix workstation to running a GUI-based software on a much less expensive PC. Therefore, the hardware costs greatly plummeted, meaning entry into GIS usage became easier. It still meant running a monolithic application package, but the desktop software allowed immediate and responsive graphic interaction with your data. For some of you younger folks, I should tell you that in ArcInfo, you did graphic editing in something called ArcEdit, and you produced a map in another program called ArcPlot, completely different modules, even with slightly different syntaxes. As PCs got stronger, running workstation software on a PC became viable. And therefore, for a good portion of this change, one could run both workstation and desktop software on the same computer. So it truly was a transition. Eventually, laptops were strong enough that you actually had some mobility. In moving away from the command line to the GUI, which most users were already familiar with because virtually all their other computing was on a PC, the number of users greatly expanded. The net result was GIS was becoming consumer-oriented. Next slide. Okay, the desktop era has had a somewhat amazing 30-year run and still going, especially for GIS professionals. We do not expect a user today, oh, the first thing you have to do is learn ArcGIS Pro. No, you go to ArcGIS Online or something like that, or simply use it on your smartphone to get a direction or something. Now here we're talking about large software applications running on PCs from different vendors, open source, but the important thing is using the common WIMP interface. WIMP, Windows, icons, menus, pointer, and the pointer usually being a mouse. Now I want to highlight a change that happens during this era. Early on, employers were apt to hire a person with GIS skills alone, even without much real knowledge of the particular domain area for their job. This was true in the workstation era and was true at the start of this desktop era. However, early on during this period, entry into the profession was greatly enhanced, if not assured, if you knew GIS software, but also knew quite a bit about the domain area. By the end of this period, and certainly in the last 5 or 10 years, employers are looking for somebody who has a little experience in GIS, but they really want a solid background in the domain area. If it's a job in forestry, they want you to know about forestry. It's in natural resources, they want that. Why? Because obtaining GIS skills is simply easier. It's not like it was a decade or two before. One of the intriguing aspects of this era, to me at least, is that GIS had a strong movement into consumer goods and services. One might purchase relatively inexpensive software to make a few maps, or simply obtain a travel route from a website. This is a bifurcation of GIS. A large and ever-growing number of GIS users, but a GIS industry that remains strongly producer-oriented, providing data and services for those consumer-oriented users. Next slide. Now, what happens in 2005? Before moving to the next transition, I want to at least spend a couple of minutes at this time. What happened was Google Maps. This was important, but the critical occurrence was the start and rapid growth of map mashups. Literally, hours after Google Maps was released, Paul Rademacher reverse engineered the JavaScript and then imported real estate data from another website, Craigslist, to create www.housingmaps.com. Rather than sue or issue a cease and desist order, Google responded in a very interesting way. They hired Rademacher and then proceeded to produce an API that would make making mashups even easier. This was not standard business practice at the time. People thought this was absolutely nuts. However, map mashups took the world by storm. Amazingly, for a couple of weeks, on the television news at night, you would see, oh, here's a new map mashup we find. They weren't called that, but said, let's take a look at this. That was actually something to be reported on. That was news. Next slide, please. The advent of map mashups was a key event, but other important changes in addition to the release of Google Maps were necessary to make things work. I'm not going to talk about these in detail, but they're all important. Computers, home computers, were now strong enough to easily handle web browsers and other things, and multi-core CPUs were starting to appear. Networks. By 2005, 2/3 of the adults in the United States used the internet, and 1/3 already had high-speed broadband access at home. The key to making Google Maps attractive was AJAX, making web pages much more responsive. Tiles were being sent rather than reloading entire pages. This made things much more interactive. And indeed, this is one of the important factors for changing the nature of the web itself. We usually have a nominal date for the rise of Web 2.0 as 2004. LBS, location-based services, had a rough go a decade earlier. Tons of venture capital had been lost. But a decade later, without making a splash, it had become strong enough to have a future. Now, what does this have to do with GIS? As it turns out, everything. Web maps, web GIS, and GIS itself are today completely intertwined. This truly was the start of the transition into service-oriented, ubiquitous GIS. Next slide. Okay, so this transition. This has proven to be more radical than the change from workstation to desktop. This is essentially a movement away from local singular application program using local data to some combination of software and data, either local or from the cloud. It's a change from the monolithic program to the platform. It's a change from using data that you house to data from anywhere. The bifurcation of GIS into consumer-oriented user branch and the producer-oriented professional branch continues. Most people on the planet are now GIS users. Most people have never even heard of the term GIS. While GIS has become more consumer-oriented, the GIS industry has, interestingly enough, become more producer-oriented. You provide data, analyses, and services for GIS end users to consume. Mobile devices require a new interface, the so-called natural user interface, where fingers replace the mouse. More recently, the natural language interface with spoken instructions has rapidly become an addition to fingers. Next slide. There is a definite defining connection between workstation GIS and the command line interface, as well as the connection between desktop GIS and the graphical user interface. Because most of us are still glued to the GUI along with a mouse for our GIS work, we think of current GIS as still being WIMP-based. But it's not. Consider that the vast majority of GIS users who might only be using GIS on their phones Also consider that a GIS professional, and this is important, needs all interfaces for their work. There's still much GIS work that requires the command line interface. It has not and will not go away. In the previous slide, I had both natural user interface and natural language interface shown. This was done to emphasize the rapid increase in the use of speech commands. Consider that speech is the modality, along with touch and gestures, that are part of the natural user interface. Given that, I suspect that a half decade from now, looking back on this, we'll see the same sort of defining connection between what I'm calling ubiquitous GIS and the natural user interface. Next slide. Okay, ubiquitous GIS. We're about a decade in or so. Devices such as the smartphone, the iPhone dates from 2007, the iPad from 2010, have changed the way we choose to interact with GIS software. Rather than having this singular huge desktop GIS package, we now interact via a web browser, or perhaps a highly focused, limited purpose app running on a mobile device. Within the past couple of years, 3 years, we have seen the integration of ML, machine learning, into GIS workflows. This will greatly accelerate in the coming years. Typically, it will not be on software running locally, but through services in the cloud. Ultimately, the Internet of Things deals with sensors, and each sensor has a location, and many sensors move. This greatly expands the types of data that are amenable, if not readily available, for use in GIS analyses. Moreover, the volume and speed of these data make machine learning really attractive. There's a fundamental difference in how GIS might be conceived. Our GIS system is no longer the large workstation or desktop software package. It's a system. It's a complex, multi-component platform. Next slide. So, looking at this, what are some of the low-hanging fruit we can talk about? Modifying the initial slide a bit and taking it out a little farther, I think it's safe to say that the era of ubiquitous GIS with billions of users will continue, at least through the decade. How long the desktop survives becomes a matter of what's going to replace it. Because this is something for the GIS professional. I do not see ArcGIS Pro or QGIS going away soon. I'm also confident that the continuous change we have seen in GIS technologies over the past 40 years will continue into the future, but perhaps at a surprisingly rapid pace. These eras I've been talking about are merely ways of categorizing and talking about different user interfaces. But various changes happen throughout an area. They are not static. The end of the workstation era was radically different than the beginning. Today's GIS world is radically different than what it was like at the start of the desktop era. It's fairly easy to predict that the speech interface modality will continue to grow until it's actually expected by most users. And that's probably going to happen really soon. If you are involved with providing content via the web or a mobile app, and you haven't been experimenting with chatbots, I suspect you start really soon. Technological change occurs at different speeds. Slow change can be easily accommodated. Rapid change can sometimes be accommodated, but occasionally fall into a category of being disruptive. The example I use for disruptive change in GIS is for those developers, GIS developers, who are wedded to either Flash or Silverlight, and what happened because of HTML5. Their development platform was doomed in a matter of weeks. Now we can move on, dealing with change. Next slide. We can categorize how to deal with change in 3 ways. Avoid change, work on the cutting edge. Those are 2 extremes, or something in the middle. spend time learning new technologies, but plan for orderly change. If we think about this, if we avoid change, waiting for a new technology to become mature, fairly mature, and waiting until there are proven paths for migrating can be really useful, efficient, and cost-effective. However, knowing when that magic time occurs might be difficult, if not impossible, if you've been ignoring the change. Working on the cutting edge can even be enjoyable if you like working with and learning new technologies. The problem is you're probably going to have to back out of new workflows periodically, which can be costly, sometimes disruptive, and occasionally even embarrassing. So it's spending time learning new technologies as they come up. The problem with this is you're going to have to invest time on learning technologies, and some of those might never be relevant for your work. And it takes time away from your day-to-day job. But the bottom line is change is inevitable. The way I've categorized them here, the last option probably looks best, but they all have downsides. Moreover, people are different. People have different learning styles, and these learning styles will impact how they deal with change. The critical thing is that you know what works for you. How do you learn new technologies? How well do you adjust to different types of change in the workplace? Next slide. Potential change to GIS jobs of the future deals with the relationship between data science and the GIS profession. So I should probably talk about this a little bit. Data science is hot right now. Many new graduate programs in data science have started over the last half decade. I've seen job announcements for data scientist positions that look like they could have been written for GIS analysts. Former students have told me about data scientists in their workplaces that are essentially doing GIS analyses without any GIS desktop software. I've had a number of former students who are pursuing degrees in data science after finishing their MGIS degrees here at the University of Minnesota. What do we make about all of this? Well, there's substantial overlap between data science and GIS. Often the hallmarks of data science come down to things like statistics, data visualization, computer science, and big data. Lists of the tools for data science often include things like Python, Jupyter Notebook, MySQL, and TensorFlow. None of these should be mysterious for a GISer. Moreover, many of these are clearly within the direction the software vendors are taking. The current training for data scientists at these newly minted master's programs looks very much like the training we are or should be providing in GIS programs. I've heard some people worry about data science. It's indeed growing very fast. Data scientists already vastly outnumber GIS analysts. Because of their ability to handle GIS spatial data, they could overrun GIS. Before commenting on this, I want to jump back into my history a bit. At the beginning of my career, I self-identified as a cartographer, specifically a computer cartographer. I went to computer cartography conferences. The early AutoCarto conferences had far more attendees than the early GIS conferences at the same time. Moreover, if you look through the proceedings of AutoCarto, it certainly looks like what we today call GIS. What happened? Basically, GIS overran cartography. Universities stopped teaching various cartography courses, started teaching GIS courses. There's a host of reasons this occurred. Having said that, could GIS be overrun by data science in the matter that GIS overran cartography? Yes, that could occur. How likely? I don't know. You, however, should not have to worry about this. If this were to happen, you'd probably be self-identifying as a spatial data scientist, or perhaps even a data scientist, before it happens. As long as you adapt to the changes that are currently happening in the GIS profession. Thank you. That's all I had to say.
Thanks, Mark. That was really great. And I think that's a great lead into some of the presentations that are coming later today, talking more about data science and its specific applications to the health industry and national security as well. I didn't see any, oh, there might be a couple new questions, but there was a question a little ways back in the chat that I think is a perfect one for you to answer. Someone was asking about jobs that don't necessarily call out GIS expertise that's needed, and organizations that aren't necessarily advertising their GIS use. Is there value in applying as a GIS professional and making the pitch and value of the value of GIS in those for those specific jobs?
I can probably answer that because early on, it had to do, early on, it had to be done with every job. When GIS, when the term itself was just being coined, when this was happening, if you would go in for a job and apply, and I've actually had students that had to tell the person that was interviewing them what GIS was. And as it turns out, what they wanted to do was just clearly what a GIS analyst does. And so early on, that was necessary. I see no reason why you wouldn't try to push it into another area today. If you saw a job that you really liked, it looked interesting, but has somehow wasn't GIS oriented for some reason, I would apply, and during an interview, try to convince them what GIS could do for them might be very helpful.
Yeah, I think that's a great example. I don't know how you could promote yourself better than by teaching your interviewers something new that they didn't know. I think that's great. We did get a couple other questions. There's some curiosity about your background. What did you study in college, and how did you jump into computer cartography from your education?
Okay, very quickly. As an undergraduate, I studied dual geography and art. Okay, what do you do with geography and art? You say, oh, there's this cartography stuff. So at the master's level, I went into a geography program and focused on cartography, but also ended up focusing really in computer science and statistics. By the way, I had more hours in statistics and computer science than I had in geography. For the PhD, I went to a geography program to do cartography, but I got very interested in computer science. However, the problem was computer science at that time was, and at the place I was at, the University of Kansas, was heavily theoretical. I was very interested in coding. I was very interested in not the science side of things, but really software engineering. And I was probably already a better programmer than anybody on the faculty of computer science at Kansas at that time. So I worked with them, but I actually have a minor at the doctoral level in computer science, but it was a little bit different. But given those things, background starting way back in art and ending up in computer science, but going through it in degrees, sort of always focusing on cartography, that's how computer cartography became the background. And it sort of morphed into becoming GIS for me.
Excellent. Well, again, thanks, Mark, for the presentation today.